So what I'm interested in are tools, the tools we use to build software systems, things like big data and security. And also another interest I have is how we can develop systems that are reliable and are developed in time and run the way we want them to run. So there are three things that I like about what I do. First of all, developing things that other people find useful, actually use them. So there's nothing better than seeing somebody use a computer and knowing that what they're doing is running something that my team and I have developed. Another thing is getting out data and information from publicly available data sets. So getting a data set that other people have developed that's publicly available and finding out concrete information from that data set. Finally, one other thing I like is harnessing the power of computers. Computers are incredibly powerful, so having computer work day in, day out, churning out things and doing calculations that we want them to do is something I found extremely rewarding. Recently we created a repository containing more than 40 years of Unix history, so you can go back and see what people have done from the 1970s until today. And this contains hundreds of contributors, hundreds of thousands of changes that have been done over the years. It's available publicly on github.com, and more than 1,000 people have actually gone there and visited that repository and seen what it contains. And this is something that I've enjoyed a lot. For someone to work in my field, I think it's important to have a concrete knowledge of systems and architecture, be good at programming and developing systems, because as we say in our group, the proof is in the pudding. So if you cannot develop a system that actually does what you are claiming to do, there's little behind it unless you actually build it and people use it. So these are the things that I'm looking on students. Other than that, it's also the ability to be able to write in a good style, to express your ideas in a way that others can understand them, and in this way to publicize your research. Students who have worked with me after finishing their PhD, they've worked both in industry and academia and also as entrepreneurs. So I have a student who built his own company, and now they have developed systems that allow anyone with very simple movements to create 3D shapes, complex shapes that can be then 3D printed. Other students have moved to universities both at home and abroad, and others are working with industry, working and developing systems such as complex cloud-based software. If someone is now at the beginning of their career, I would say first of all, get a broad exposure to multiple things. Go and visit conferences if you can. If you cannot, at least get the proceedings. They are available from sites such as the Digital Library of the IEEE Computer Society. Browse the tables of contents and read a few papers that actually interest you to get a picture of what is going on, what's exciting in the field, and particularly in the areas that interest you. Make it a habit to read a few magazines such as IEEE Computer or IEEE Software, IEEE Security and Privacy, to see what's going on in a matter that's accessible. And if you can, also try at least to read the tables of contents of transactions to see what heavyweight research looks like, and try every so often to read one paper from start to end to see how a research paper is structured. So things that an undergraduate student is studying and the relationship to what I'm researching. One particular example concerns programming. So just as in programming you create objects and you manipulate your properties, what we are currently researching is how these objects can be complete elements of the cloud, so computers or networks or other cloud abstractions. And just as you manipulate the elements of an object and you change its color or velocity, you can change the properties of a complete computer, changing the memory it has or the number of processors. So just as you write a program and you create a video game, you can write a cloud-based program that changes the way cloud configuration works and the way computers are configured in the cloud.